start the recording. Okay, whoa, look at this. Look at this matrix here. Look at this. Look at this problem. It says, find the general solution of the linear system whose augmented matrix has been reduced to this augmented matrix here. So again, they don't show the dashed lines like some books do that separate out, the coefficient terms from the numbers to the right of the equal sign. But we can see there, well, how many equations are there? How many equations are we dealing with here in this problem? 3 equations. How many variables? 5. Good, good. All right, let me give you a moment to copy this example down. Benjamin, that's right. But with triangular form is equivalent. That's right. Very good, Catherine, Olivia, Eleni, and hold on here, and Eleanor. That's right. Now, hey, okay, Dr. Duty, I can't quite draw a triangle here, but hold on here, one moment. But the bottom left corner of the matrix has zeros in it. So it's in triangular form, it's in echelon form, but we want to know about the solution. We want to know, hey, what's x1 equal to? What's x2 equal to? What's x3 equals to? What's x4 equal to? What is x5 equal to? So I need to do a little more reducing. Well, what's x5 equal to? What's x5 equal to based on, x5 equals 7. But now we have to get expressions for the rest of the variables. That's right. Good. So who could, we'd like some more zeros. We'd like some more zeros. Where do we want our zeros to be? Who maybe could circle a couple of numbers that we would like to become zeros? Whoops, hold on, I gotta click here, right. Yeah, okay, well, that's okay. That one, That one, we want to leave that one alone. We want to leave that 2 alone there. Hold on. All right, sorry. Once again, the 8, then I'll tell you what, hold on. I got it. Hold on. I'm going to be more clear. I'm going to be more clear. Let's focus on the 5th column here. Okay. Could you circle in red? Okay. Okay, good. The -2 and the -1, we want those to be zeros. Okay, we want those to be zeros. So we're going to use the number 1 as a what? It's the P word. 1 is going to be our pivot. That's right, Catherine. Good, good. Okay, so let's proceed on to the next page here. Let's proceed on to the next page. And there's a lot of writing here, but this part here, you don't really need this. Okay, what I'm trying to say is don't well. All right, I'll just, I guess it's fine. It's fine. So formally, you're going to learn what echelon form and reduced echelon form are. We'll go over the definition of that. Well, I mean, I guess I can do it now. Hold on. No, I don't want to do that. I want to. I believe when we do things, when we learn by doing, and then the definitions will make sense. But this is in the matrix, the augmented matrix is in echelon form, but we want to have it in reduced echelon form. And that means we want to have zeros where the -2 and the -1 are. Okay, we want to have a 0 there. And also we want to have a 0 where this 2 is. Okay, because you see the 1 here is a pivot. That leading 1 for that 3rd equation, that 3rd row, is a pivot. It's the leading number. And then for the 2nd equation, the 2 is the leading number, the leading non-zero number. So the leading non-zero numbers are pivots. And we use pivots to produce zeros in the remainder of the column. So when we do that, we'll get the matrix in reduced echelon form. Okay. All right. So we want the matrix in reduced echelon form. I had page numbers here, but don't worry about the page numbers. I'm just, let's just. So using row reduction, using that 1 as a pivot, I'm going to get zeros in these 2 spots by using these 2 row operations. Okay, let me give you a moment to copy that, and let's see if you have any questions. If there are any questions on like how I got the -4 and the 3 here, just let me know. And we will use this 2 here as a pivot to produce a 0 above. However, I notice that the second row or second equation, since all the numbers are even, it's no big deal to take the second row, multiply it by half, and put that result into the second row. And that's what we do then for this next, that's what we've done to produce this next matrix. And now that we have the 1, that 1 is a pivot, we'll just take the second row, second equation, multiply it by -2, and add it to the first row. And then that result goes in the first row. And that'll get us down to this matrix here. All right, so at this stage here, this matrix, is there anything more we can do to break that matrix down? Or have we basically broken the matrix down, reduced it as far as we can? I mean, we can always do row operations, but we don't want to do row operations that are going to produce non-zero numbers where zeros were. You know what I mean? I mean, we don't want to do anything that's going to make the matrix harder. If we look at it here, the 3 pivot columns, which are the first column, the third column, and the 5th column, they're called pivot columns because they have pivots in them. Those ones, you know, we can't do anything more with those. Those are reduced as far as we can go. So I mean, this matrix is now in what's called reduced echelon form. So I'll go to the next page, if I may, and now write that augmented matrix as, I'll write down the associated system for the augmented matrix. Here's the associated system. We started out with, we have 3 equations with 5 variables. Based on what you see, so we have, do we have more variables than equations or more equations than variables? We have more, that's right, we have more variables than equations. In other words, we have 5 unknowns, but only 3 equations. Now, I want to be careful. That doesn't necessarily mean that I want to be careful. Intuitively, we would think, gee, you know, if we have more variables than equations, that we're not going to get a solution that's going to be like a single point, okay, like a single coordinate, you know. But I'm not saying it. I want to be a little bit careful here. Well, in fact, no. That's right. We have more variables than equations, so we're not gonna get like one solution. We're gonna get an infinite number of solutions in this case with what we have. So what would the solution be? Well, now this is something you would not have seen before, but look, x5 equals 7. Okay, we're going to let x4 be what's called a free variable. We can't specify numbers for all the variables. x4 is going to be free. But then based on the second equation, that means if x4 is free, that means x4 could be any number you want. But x3 is not free, because based on the second equation, based on this restriction, x3, if x3 minus 4x4 equals 5, that means x3 will equal 5 plus x4. Okay. And now, well, we're going to let x2 be free, but then based on the first equation, since x1 plus 6x2 plus 3x4 equals 0, that means x1 would have to equal negative 6x2 minus 3x4. So you see, you have what are called free variables, and those variables could take on any value, but then you have 3 basic variables which are x1, x3, and x5. The basic variables are written in terms of the free variables. Okay, and so this is an example. We have a is the system consistent? Is the system consistent is this system of equations consistent or inconsistent? What do you think? Well, did we get a solution? Did we get a solution? Oh, this isn't a solution here? It's a solution. It's just there are an infinite. It is. Okay, it is. It's just we have an infinite solution, infinite number of solutions. Okay, because we can, if we let x2 equals 3 and x4 equals 5, then we can solve for x1, x3, and x5. If we pick other values for x2 and x4, you know, we could solve for x1, x3, x5. In other words, there's an infinite number of solutions. So this is a consistent system, but you have what are called free variables. And this is I think a good. I mean, I'm glad you saw this before we stopped today. We're going to pursue this a little more on Thursday's class. But are there any questions? At least I know it's going to take time to absorb, but are we comfortable that, hey, that we did get out a solution? It's just the solution is there are infinite solutions. It's not like the solution is one coordinate. It's an infinite number of coordinates that form a subspace in it's a subspace in I want to be careful. Well, we won't get into that yet. But are there any questions on that?